These are your notes on Boyle's Law, and they're also going to be on some pressure conversions. While you're taking the notes, pause the video whenever you need to make sure that you get all your examples written down and all the blanks filled in those fill in the blank notes. So Boyle's Law in the last assignment, we already discovered that it shows the relationship between volume and pressure. And we know that if it's going to show that volume and pressure, remember we were selecting certain boxes in that PhET simulation where the temperature and the amount of gas had to be held constant. So we selected a box where the temperature had to be constant. And then remember, we pumped in 2 or 3 pumps of gas, and so the amount of gas was also held constant. So atmospheric pressure, you have to realize that we're surrounded by gas all the time, and that gas does cause pressure, right? All of the oxygen and nitrogen and carbon dioxide in the air, they are moving around just like the gases shown in previous simulations when they're in their containers. It's just the room you're in, that's the container of the gas. And so it's bouncing off the wall. Well, it's also bouncing off of you. And it's bouncing off of your desk, and it's bouncing off of your pencil and your cup and everything else in the room. Well, every time that that air particle hits something and bounces off of it, it causes pressure, right? So you can weigh it or measure it by measuring the weight of the air in the atmosphere above you. That's one way to get it. So what you're going to find out is there's a bunch of different ways that we can record pressure. We can record pressure in ATMs. That tends to be the standard. So 1 ATM of pressure is, there's something called standard temperature and pressure. So it's basically at sea level, the pressure is 1 ATM if you're at the standard temperature of 0 degrees Celsius. So this PA here, that is a Pascal. That tends to be the more formal way or the more scientific unit we use to measure pressure. Millimeters of mercury, I'm sure you guys have heard of a barometer before. Well, in a barometer, what happens is there's this atmospheric pressure that's pushing down on a barometer that's filled up with mercury, and in this tube, the level of mercury rises depending on the atmospheric pressure, and we measure the height of that tube of mercury in millimeters. So there's a unit of millimeters of mercury. Torr is just kind of another random unit, pounds per square inch. That's probably something that you've heard before, maybe in a math class. And then this last one here is kilopascals, which is really just our pascals converted into kilo, right? To go from a standard unit to kilo, you move the decimal 3 places to the left, and that's what happened. The decimal place was here, and we moved it 1, 2, 3, and we got this 101.325 kilopascals. We're going to use those to convert between units. That's what we're going to do here on the first page. So atmospheric pressure conversion. So I left those conversions up there at the top because we're going to need them. So convert 856 millimeters of mercury to ATM. Well, we know that there's 760 millimeters of mercury for 1 ATM, and we're going to use that for our fraction. Now we want these units of millimeters to mercury to cancel out, and remember in our lesson 1, you guys did some metric review and some unit conversion review. You'd be using that unit conversion skill. So if we want the millimeters of mercury to cancel out, we need that unit to be on the bottom of the fraction so that these units cancel, and so we put our 760. And then we're trying to get to the units of ATMs, so that's what goes on the top of the fraction, and we know we're going to use 1 ATM. So because that 760 is on the bottom of the fraction, you would do 856 divided by 760, and that will get you, your calculator is going to read all of these decimals out. Well, this number here, this is 3 sig figs. So if I'm done, I need to round my answer to 3 sig figs, right? This would be my answer. Now, if we're going to use this converted number in another calculation, like we are later on in these notes, notice that here's the 3 sig figs I said I needed to go to, and I took it to 2 places further. If I'm going to use this number for another calculation, I'm not going to round to sig figs, then make another calculation, and then round that to sig figs. That you don't want to keep rounding. So if I go two decimal places or 2 significant figures more than I need, then it's not going to hurt me to round a little bit and then round my answer again. So our next one, let me get rid of all this writing that's on here. If I can, see if I can figure this out. Oh, that's not what I wanted. There we go. Okay, so our next problem, right, 451.3 kilopascals. So here's kilopascals, and we want to go to pounds per inch squared. Now, neither of those are 1, and that's okay. It'll still work. I need kilopascals to cancel, so that goes on the bottom of my fraction, so that these units cancel out. And, right, I got that 101.325. Now I want to get to pounds per inch squared, so if I look here, well, 14.7 pounds per inch squared equals 101.325 kilopascals, so that 14.7 goes on the top. So now in your calculator, you're going to do 451.3 times the top of the fraction, 14.7, divided by the bottom of your fraction, 101.325, and you're going to get another long stream of numbers in your calculator. Well, this here is 4 sig figs, and so because I need to round my answer to 4 sig figs, that's what I did here. Notice here I went to 6 sig figs, because if I had to use this number for another calculation, I want to go 2 past the 4 that I would normally round to. At this point, you can pause the notes, and if you look further down in your homework, or notes/homework, you'll see that there's a couple of these pressure conversions that you can do. So you could go and do those, or you can go to the next video and finish up the notes.